Hello, calculus folks. What we're going to do in this video is we are going to try and understand how to write the equation of a tangent line. Now, a tangent line is a line that touches or sort of just barely touches a function curve at one point. Let me show you what I mean by that. Let's say that we have the graph of a function that does something like this. Okay? At any one of these points along the curve, we can pick any point, and we can, at that point, we can draw a line that just barely, hang on, let's see if I can get this right, it just barely touches the curve at a single point. You see that? And what will happen is, as you move the point along, what will happen is the slope of that line will continue moving along, and when you come down here, it'll actually go underneath, because when you have a concave up curve, the tangent line is underneath. When you have a concave down curve, the tangent line is on top. Okay? And so we'll come over here and draw another one. It barely touches in one place. Okay? And sometimes what we want to know is we want to know what the equation of this tangent line is. Now here's something that you need to understand in order to do that, is a tangent line has the same slope. It has the same slope as the function, as the curve of the function that it is tangent to. So, at this point right here, at that point, this tangent line has the same slope as the slope of the curve, of this curve, at that very point. So what we can do is, since we want to write the equation of a tangent line, all lines have a slope. It's one of the defining qualities of a line. All lines have a slope. And so what we can do is we can use the function itself. If we can identify the slope of the function at that point, we can also identify the slope of the tangent line at that point. And you have just recently learned how to identify the slope of a function at a point, and that's called the derivative. So if you can find the derivative of a function at a point, then you can identify the slope of a tangent line. Okay? So let's go ahead and review how to identify the equation of a line. You're probably familiar with the slope-intercept form, y equals mx plus b. It is probably the most popular form of a line in a high school math class, or in a high school algebra class, or analytic geometry class or something. But it is the hardest one. Well, it's not the hardest one, but it's actually more difficult to use the slope-intercept form when you're identifying the equation of a tangent line. Because in order to do the slope-intercept form, you need a slope and a y-intercept. Or you can have a slope and a point and then do a whole bunch of algebra. But there's an easier form of a line. It's called the point-slope form. Point-slope form. And it looks like this. It's a parenthesis, y minus y1. And y1 is an actual number. The y stays as a letter, and the y1 is an actual number. It's a y value from a point. Y minus y1 is equal to m, as in slope, m, same m as up here, slope, times x minus x1. And so the x1 is also a value. It's the x value of a point. So in order to identify the equation of a line in point-slope form, you need, this is supposed to be an x, I'm sorry, It's not a y, it's an x. There we go. I didn't go far enough. Okay. In order to identify the equation of a line in point-slope form, you need two things. You need a point and you need a slope. So let's say that we had the point 4, 7, and we had a slope of -3. So we have the point 4, 7, and we have a slope of -3. With these two pieces of information, we don't even have to do any real work to identify the equation of a line. What we would do is we'd take the y value 4, or excuse me, the x value 4 and put it in for the x value here, x minus 4. We would take the y value 7 and put it in here for the y value, y minus 7. And then we would take the slope, -3, and put it in here for the slope, and we'd have a -3 here. So our equation would be y minus 7 equals -3 times x minus 4. And this is the equation of the line, that has a slope of 3 and passes through the point 4, 7. Okay? So this is how we use point-slope form. So now let's go to identifying the equation of a tangent line. Okay? All right, here's a pretty much easy run-of-the-mill kind of question that might be asked when you want to find the equation of a tangent line. What is the equation of the line tangent to the function f of x, where f of x is equal to x squared, at the point where x is equal to 8? And we want to use point-slope form to answer this question. Well, in order to use point-slope form, you need a point, an xy point. That's an x1 and a y1. You need an x1 and a y1. So you need a point and you need a slope, or m. Okay? Now, to find a point, you need either the x value or the y value. Well, in this question, you're given the x value of 8. So we already know x1 is 8. So now we need y1. We need to know what is the output value when x is equal to 8. Well, the way we find an output value with a function is we just plug our x value into the function. We need to put 8 in here. We need to know what f of 8 is. Okay, let me change colors here. So, x is equal to given, right? We're given that. It's 8, right? Y is going to be equal to the function when you plug 8 in, which in this case is going to be 8 squared. 8 squared, which is 64. So now we have x1, we have y1, and now we need a slope. Now here's the part, this is the calculus part. Everything else here is just algebra. Now we're getting to the calculus part. Remember that the slope of the tangent line is equal to the slope of the function at that point. And the slope of a function at a point is given by the derivative. So here's what you basically need to do. To find the slope, you're going to do the derivative, f prime, and then you're going to plug in the given x value. It's going to be f prime at x1. So first, that's going to be equal to the slope, m. And so m, the slope, this is x1 and this is y1, sorry. The slope is going to be equal to the derivative f prime with 8 plugged in. Well, what is the derivative? If f of x is x squared, then what is f prime of x? What is the derivative of x squared? It's 2x, right? So f prime of x is 2x. So f prime of 8 is going to be 2 times 8, which is 16. So now we have a slope, x1 and y1, And now all we have to do is plug them into the point slope form, right? And what is the point slope form again? It's y minus y1 equals m times x minus x1. And so here, we're just going to plug it in. Parenthesis, y minus, whatever y1 is, 64, equals slope m, 16, times x minus x1. And x1 is 8. And so this is the equation of the line tangent to x squared when x is equal to 8. Okay? Let's do another example. All right, here's another example. It says, what is the equation of the line tangent to the function g of x? G of x is defined by sine of x at x equals 0. Okay? So here's what we need. We need an x1, we need a y1, and we need an m. That's our slope, right? Well, x1 is given to us. x1 is 0. So now we need an output value, y1. Well, that's going to be whatever, we're going to plug 0 into g of x. So this is going to be g of 0, which is sine of 0. Okay, we got that one. Well, what is sine of 0? Well, you got to know your trig, your unit circle, right? You could use a calculator and find this, but if you do, make sure that you are in radians, okay? So we're going to plug 0 in. Sine of 0 is equal to 0, okay? Sine of 0 is 0. So we've got an x value, 0. We've got a y value, 0. And now we just need a slope. Well, to find the slope, we need to take the derivative. So here's what we do, okay? Take derivative and plug in x1. That's the x value that was given to you. Derivative, plug in x. All right, well, if g of x is equal to sine of x, well, what is g prime of x? What is the derivative of sine of x? Well, if you learned your trigonometric derivative rules, we know that the derivative of sine of x is cosine of x. Okay? And so now we just need to plug 0 into cosine of x. So the slope is going to be g prime of 0, which is cosine of 0, which is equal to 1. And so we have x1, we have y1, and we have a slope. Okay? And so we're going to use our point slope form here. What you're going to find is a very interesting problem. It comes out very, very interesting. And we're going to do y minus y1, which is 0, is equal to the slope m, that's 1, times, parenthesis, x minus x1, which is also 0, right? Now, what is y minus 0? That's just y, right? And what's x minus 0? Well, that's x, and x times 1 is just x. So interestingly, the equation of the line that is tangent to sine of x at x equals 0 is actually the graph, the function y equals x, which is the identity function. Okay? So that was kind of an easy one. Let's do one more example, shall we? All right, this one's sort of crazy, and we're going to have to use a calculator. Well, we don't have to use a calculator, but I'm going to use a calculator so that I can show you that I'm okay with you using a calculator. Now, if you're taking a calculus class where your teacher or professor hates calculators, then you're just going to have to figure out how to do this without a calculator. Well, maybe I'll do it. Maybe I'll do it without a calculator, and I'll show you how you can do it. Okay. But first, I'm going to do it with a calculator. Here's what it says. It says, what is the equation of the line tangent to the function? Here's our function. H of x, it's this whole thing, is 3 to the x power plus the natural log of x minus 5 when x is equal to 2. Okay? So here we need 3 pieces of information for this line. We need x1, we need y1, and we need m, the slope. With these 3 pieces of information, we can plug them into the point slope form, and we'll have an equation of a line. It really is that easy every single time. So x1 is given to us. We're given 2, so that's our x value. Now, to get our y value, we need to plug our x value into our function h of x. So we need to know what h of 2 is. So we'll plug 2 in here. So it's going to be 3 squared plus the natural log of 2, 3 to the second power plus the natural log of 2 minus 5. I'm going to do this in a calculator, but later on I'll do it without a calculator, okay? All right, so we'll do 3 squared plus the natural log of 2 minus 5. And that gives me 4.693147,181. All right, now I really only need 4 decimal places. If it's the AP Calculus exam, they're concerned about 3 decimal places. I like to go to 4 decimal places just to make sure. So it's going to be 4.6931. And that's rounded or truncated because the next number after that is a 4. So we're good. Okay? All right, so I've got that. I probably need the calculator again. And now I need the slope. To get the slope, I need the derivative. So to find the slope, we do the derivative of the function, then plug the x value into the derivative. That's how we get the slope at the point. So we need h prime of x. So we need the derivative of 3 to the x power, which is going to be 3 to the x power times the natural log of 3, plus the derivative of the natural log of x is 1 over x, right? Okay, so plus 1 over x, and the derivative of a constant is 0, so this just drops off for the derivative. So here's our derivative, h prime. And so we need h prime of 2. We've got to plug 2 in for all the x's here. There's an x and there's an x. So that's going to be equal to 3 to the second power times the natural log, oops, that's an h, that's not an ln, times the natural log of 3 plus 1 over 2, because that's what we're plugging in, 2. So that's 1/2, right? Let's see what that's equal to. So we'll do 3 to the power of 2. Then we're going to multiply that by the natural log of 3. And then we're going to add 1/2. Okay? And that gives me 10.3875. 10.3875. So now I'm going to write the equation of my line using this information. I'm going to plug 2 in for x1. I'm going to plug in 4.6931 for y1. And I'm going to plug in 10.3875 for m. So the equation of my line is going to be y minus 4.6931 equals m, the slope, which is 10.3875, times, parenthesis, x minus 2. X minus 2. And this is the equation of my line. I don't need to simplify it. I'm going to leave it just like that. That's the equation of my line. Now, I said that I was going to do this again without the without using a calculator, right? Oh, Mr. Ryan, I'm not sure if you can do that. I don't know that kind of math. That's okay. No, it's really easy. This is still our derivative. This is still our x1. Here's what we're going to do. Is for y1, we're actually just going to leave it like this. This is our y1 right here. Now we could go ahead and do 3 squared. 3 squared is 9. So we'll change that to a 9. And 9 minus 5, that's 4. 9 minus 5 is 4. So what we really have, our y value, is 4 plus the natural log of 2. We'll just leave it as 4 plus the natural log of 2. That's a number. So we'll leave it. Coming down to the derivative here, we won't use this decimal because we don't have a calculator. We know that 3 squared is 9. Okay, 9. 9 times the natural log of 3, and then plus 1/2. And we'll just leave that as 1/2. We can't add here. We can't do 9 plus 1/2 because this is 9 times natural log of 3. And because this one doesn't have a natural log of 3, they're not like terms. So we're going to leave it just like that. That's our slope. And now we're going to plug 2 in for x. 4 plus natural log of 2 in for y, and 9 times natural log of 3 plus 1/2. We're actually going to put this in parentheses when we plug it into our formula. And so it's going to become y minus, and I'm going to put this in parentheses too. 4 plus natural log of 2. There we go. And that is my whole y part, okay, equals slope, which is 9 times the natural log of 3 plus 1/2 times x minus 2. And there we go. This is now the equation of the line. That's the equation of the line. Looks a little crazy, but that's what you do. When you don't have a calculator, you just put the things that you would need to calculate in a calculator and just put them right in there in the function. You just have to be extra careful with your parentheses, okay? So this is how you find the equation of a tangent line.